Okay, so we are now moving on to section 11.2, which is solving linear systems by substitution. So just as a reminder, when we solve systems of equations, we are trying to figure out where the graphs, in this case, where the lines intersect. And so far we've done solving by graphing. So that's done by graphing the equations and then figuring out that ordered pair where they intersect, if they do. Today we're going to be learning a new method, which is called the substitution method. So we'll first start off by defining what substitution method is. So what you are going to be doing is you're solving an equation for one variable. Remember, a variable is just a letter in the equation, so typically x or y. So solving an equation for one variable and substituting. So that kind of is like almost replacing the resulting expression into the other equation. So the best way to kind of see this is actually to do a problem. But essentially, we're going to solve an equation for one of the variables, and then whatever we get as that resulting expression, we plug it into the other equation for that variable. So we're going to start off with 3x plus y equals -3 and -2x plus y equals 7. The first thing I'm going to make a little note here is you want to, and I'm saying try because you can't always, so try to choose equation that has a coefficient of 1. So you can't say, a lot of students say, oh, because it doesn't have a coefficient. So everything has a coefficient. It's just if there's no number there, it's just 1. But you want to choose an equation that has a coefficient of 1. So looking at both of these equations, they both have y by itself, meaning you don't have like a 2 in front of it, or in this case, a 3 or a -2. So we can actually pick either one. I'm going to just go ahead and use the second one just because. So again, what I want to do is I want to solve that equation for y. So I'm trying to get y by itself. So when I do that, I basically am just going to add 2x to the other side. So I get y equals 2x plus 7. Okay. And what we want to do next is, like it says in the problem, we want to take that resulting expression, which is 2x plus 7, and I want to plug it in the equation for y. So when I do that, I would get 3x plus, and instead of y, I'm going to actually put in 2x plus 7. Okay, and then that would be all equal to -3. So all I did was replace y with 2x plus 7. The reason why we can do that is because 2x plus 7 is equal to y. So then we're going to go ahead and combine like terms. So we would have 5x plus 7 equals -3. We're going to continue to solve. So we would add 7 to both sides and get 5x is equal to -3. Sorry, I should have subtracted 7. So -3 minus 7, which is -10, divide by 5. So we get x is equal to -2. Okay. So now that we have the x, remember when we solve a system of equations, we're trying to figure out the ordered pair of where those lines intersect. So all we have is the x, so I'm sure you guys can guess. To get the y, we plug in that x value into one of the equations. So I'm just going to make a note here. So we are going to plug in value into either equation to solve for other variable. Okay. So I'm going to take that x value of -2 and plug it into either equation. It doesn't matter which one. So I'm going to use the one that's already solved for y. So y equals 2x plus 7, but instead of x, I'm going to substitute in -2 plus 7. So y equals -4 plus 7, so y equals 3. So for my final answer, it would be -2, 3. So that is where the lines intersect. Okay, so let's go ahead and try another one because that first one is kind of like a learning process. So looking at these two equations, remember your first step is to figure out which variable you want to solve for. So for example, looking at the first equation, I wouldn't choose to solve for y because it's a little bit of extra work. So I'm going to just go ahead and use the first one and get x by itself. So if I were to get x by itself, I would get x equals 3y plus 9. So I'm going to take that 3y plus 9 and I'm going to plug it into the other equation for x. So this would become 3y plus 9, so that's my new x, plus 4y equals 2. And from there, you are going to just combine like terms. So we would have 7y plus 9 equals 2. Then subtract 9, so we would get 7y equals -7. Divide by 7, so y equals -1. So last time we got the x first, this time we're getting our -1 first. So now I need to plug in -1 into either equation in order to solve for x. It's typically easiest to solve it in the one where it's already in x equals form or y equals form, for example. So I'm going to use the top equation up here. So x equals 3y plus 9. So I'm just going to put in -1. X equals 3 times -1 plus 9. So x is equal to -3 plus 9. So x is equal to 6. So where they intersect is going to be 6, -1. So that ordered pair, that point makes both equations true. So just like we had special cases for graphing, we will for substitution, because keep in mind we're both doing the same thing. It's just different methods of solving. So for this, we are going to look at another example. We're going to just go about it the same way that we have been doing. So I'm going to go ahead and just solve the first one just because it's convenient, and I'm going to solve for y. Why not? So if I solve for y, I would get y equals -x plus 4. So I know that I have to take that y value and put it into my other equation for y. Okay, so this would turn into -x minus. Now this is important. So because it has that minus there, remember it's minus that whole entire y value. So I actually have to put parentheses over the -x plus 4. And this is all equal to 6. So the next step would be to deal with these parentheses. So I'm going to distribute that negative sign, thinking of it like a -1. So this would be -x. This would turn into plus x minus 4 equals 6. Now the -x plus x, that just cancels out. So we end up getting -4 equals 6. Okay, so first of all, this doesn't really make sense because we don't have our variables. The other thing is -4 is not even equal to 6. So in this case, this would actually be no solution. So this means that if I were to actually graph these equations, they would be parallel lines. And you don't have to write that down. I'm just noting that. So if you get no solution, remember in your mind that that just means parallel lines. Okay, so just as a reminder, when you're solving systems of equations by substitution, you will get, if it's a unique case, you'll get like a number equals a number. And if it is not true, then it would be no solution. So now we're probably wondering, well, what would it look like if it's infinite solutions? And that's what we're going to find out right now. So I am going to go ahead. This is actually a good example for why we would want to use the first equation. So we could use the second equation, but it's going to make it a little bit more complicated to solve for either x or y. So I'm going to use the first equation because it's easy to solve for x. So to solve for x, I would just add 3y to the other side. So I get x equals 3y plus 6. Now I have this entire thing is equal to x, so I need to plug it into the other equation for x. So just like we did before, I need parentheses. So it's going to be 4 times, this would become 3y plus 6, because that's my new x value, minus 12y equals 24. So I have 4 times 3y, which is 12y, 4 times 6, which is 24. Then I have minus 12y equals 24. So the 12y and negative 12y cancel out, and I end up getting 24 equals 24. So once again, this doesn't really make sense, right? I lost my variables, but unlike the other time, we had two numbers that don't equal each other. This time, these numbers actually do equal each other. So in this case, this would mean infinite solutions. So if you happen to be solving algebraically and you get something where it's a number equals a number, and that actually is true, that's where it would be infinite solutions. So what this means is these are actually the same line. And I think by, a couple weeks from now, we probably would have been able to tell by looking at the equations. If you look at them, it's the same equation. The second one's just multiplied by 4. So you can kind of think of it as leaving a fraction as 4/8 as opposed to 1/2. So this is 11.2, solving systems of linear equations by substitution.